Your homework for tonight is a practice worksheet. There's another outline on Google Classroom for you. There's also an answer key. So make sure you are checking your work. If you have not already emailed Mrs. Kane or I about scheduling a retest, if you plan to take one, or if you got an email from us about completing the extra practice worksheet, please do so. That must be done by Friday. And your test is on Monday. Questions for us? Today's the last day of actual material for your test on Monday. Tomorrow and Friday are just review. All right, so go ahead and pull that homework out. I want to first talk about 1A. Here said, what is the mathematical term used to describe the graph of this equation? So it's talking about that term that describes the graph. This is not that standard, what type of form it's in, but what term do we use to describe the graph? Helene, what did you think? Or go ahead, Malachi.
Parabola?
Yeah, a parabola. So I saw a lot of like standard here because it's in standard form. What we were talking about, the term to describe the graph, and that's a parabola. It's called a parabola. Another misconception I saw was for each problem it asked, does the graph open up or down? So when our first term A is greater than 0, Alyssa, does it open up or down?
It would open up.
Yes. And so if it's opening up, then we have a min. And if A is less than 0, it will open down and we'll have a max. So I saw some of them confused on this part. You can always draw a parabola to the side and look, so will this have a max or a min? If you can tell whether it opens up or down. Okay. Wanted to talk about number 8. There was also a number 9 on this review worksheet. Some students didn't see that last problem and just submitted it. So number 8 says a grocery store sells about 36 packs of bubble gum per day at a price of 45 cents each. For each $5 increase in price, the store expects to sell 2 less packs per day. Write the quadratic function in standard form that models the revenue from bubble gum sales. So we know we're writing a function. What are the 2 different parts here that will go into this function? Ava R., what are the 2 different parts?
The price and the packs, like the gum packs.
Yeah, good. Can you give me what you wrote down for the price part?
0.45 plus 0.05x.
Awesome. Good. And Ella, can you tell me what you wrote down for the second part of this function with the number of packs sold?
I wrote down 36 minus 2x.
Awesome. Did anyone not understand this part, how we got those binomials? So it's asking us to write it in standard form. Can we leave our answer like this? Yeah, I agree, we can't. I see a lot of shaking heads. We have to FOIL. Standard form is when it's in that y equals ax squared plus bx plus c form. So we have to FOIL. When you end up doing that, you will get 16.2 minus 0.9x plus 1.8x minus 0.1x squared. When you combine like terms here and have the powers in decreasing order, you will have negative 0.1 squared plus 0.9x plus 16.2. So this is in standard form. This function represents the change in bubblegum price versus how many are being sold. So they're saying, should the store change the price of bubblegum to maximize revenue? Grace, what should we do here?
I wasn't completely sure on this part. Were we supposed to do negative b over 2a?
Yes. And that's because we want to get that axis of symmetry, which will then help us get that vertex. And the vertex is where this max is. We can see that our A here is less than 0. It's opening down. So that vertex will be the max. That's what we want to find. So yeah, Grace, we're going to do that x equals negative b equals 2, or negative b over 2a. So we have negative 0.9 over 2 times negative 0.1. And we end up getting 4.5. Jaden, what should we do after this once we get that x equaling 4.5?
You should plug it in for all the x values in your standard form equation.
Good, and what will that give us? What is that once we plug that in?
I got 18.225.
Yeah.
Okay. I wasn't sure if that was right or not, but yeah.
Yeah.
Okay.
18.225, and if we're talking about money here, then we'll round up and we'll make that 18.23. This means that max point is at 4.518.23. So we have to answer the question. They're saying, should the store change the price of bubblegum to maximize the revenue? So should we change the price? Shake your head, yes or no? Yes, I agree. We need to change the price. Now, remember, this is where I saw, this is what was missing from some answers. That first part highlighted of that function, that 0.45 plus 0.05x, that's the price part of the function. Remember, we have to plug that x equaling 4.5 back into there to describe what we should change it to. So I'm going to do it down here. 0.05 times 4.5. That ends up giving you 0.23. This is saying that we should increase the price. We have an addition there. We should increase that price of the bubblegum pack by 23 cents to reach that maximum or to maximize profit. At 18.23. So that 0.05x, that's what we should change the price by. The 45 cents, that 0.45 is what it already is at. And that second part is what we should change the price by. Questions here? Okay. Jaden.
Sorry. No, so for the like how to like decrease the price or whatever or increase it, so like wouldn't it be 36 compared to 18? Or would that like you know what I mean, for like packs being sold? So like I was confused like why that how to increase it or whatever.
Where did you get the 36 and 18? Where do you see that?
Well,
For the-
the 36 is from the original like problem where it says like they sold
Oh.
36 of packs of bubble gum. And then wouldn't it be like they're selling 18 packs of bubble gum for like the Y value, or is that not right? Or is that something representing something else?
So, good question. That 18 here, that's representing dollars, the profit.
Oh, okay.
Yeah.
Okay, that's why I was confused, because I was like, why would you want to increase it if you're going from 36 to like 18? I got it now. Thank you.
Yeah, 36 is just the amount of packs that they're currently selling.
Okay.
But again, we're only selling them for what, 45 cents? So
Okay.
you're not even making $18. But we want to maximize the profit at 8. Yeah, that's what that 1823 means, the profit, money, how much money we're going to earn from changing
Okay,
that.
thank you.
You're welcome. That was a good question. Alyssa.
This doesn't really have anything to do with the problem. This is just like a question in general. I was wondering how you can decide if the parabola is like wide, standard, or narrow, because I was confused with that part.
That's a good question. All right, so let's go back and look at the first page. So here we have A equaling 2. So its standard width, the graph or the parabola would be standard if that A value is 1. If it's just x squared, y equals x squared plus whatever comes after it. A equals 1 would be standard. So if A is greater than 1, like here we have y equaling 2x squared plus 8x plus 6, then this would be narrow. So let's look. So on a calculator, the first graph I'm gonna have is x squared. The next one, I'm gonna put 2x squared. So we can see that our A value is greater than 1 there. So our blue one is A equals 1 and black is A equals 2. You can see, let's zoom out here. I guess it doesn't want to zoom out. You can see the blue, again, was A equals 1, and the black was A equals 2. So when A is greater than 1, the parabola is going to be narrower. It's going to come in. So now let's also look when A is less than 1, like 1/2. So that one's going to be red. That one's wider. So when A is greater than 1, it's going to be narrower. And when A is less than 1, it's going to be wider. And when A is 1, it's just standard. That's your standard parabola. That's the parent graph, parent function. So let's look back at these examples. I explain everything loves to take a bit. So if you look, example 1 was at A of 2. So we know that it's going to be narrower. In number 2, it's A is negative 2. So even though it's negative, it's still going to be narrower because A is 2. The negative just means it's reflected over an axis. It will be reflected over the x-axis. So then if you look for 5, what is our A value for 5?
Me?
Yes.
Okay. It would be 0.25.
Yeah, that 1/4. That, what do you think that means the parabola would be? Narrow, standard, or wide?
It would be wide.
Yeah, because that A is less than 1. When it's less than 1, it's going to get wider. When it's greater than 1, it's going to narrow. Does that make more sense, seeing it graphically?
Yeah, it does. I just didn't know like what to look at when deciding.
Yeah, I think it's somewhere in our notes way back a few sections ago, probably. But yep, that's it. Ella, question?
Yeah, on number 8, I'm not sure how you got the final answer of 23 cents because I plugged the X value back into the price parentheses and I got 68 cents.
Good. Glad you brought that up. So you could have, that means that I just took this part, I'm going to highlight it, just that 0.05 times X, because that's what the price would be changing, but you added
Okay.
0.45. So that means the total price of the pack of gum we should sell it for is 68 cents. And that's totally fine. That's good. You're saying that we should sell the total price of the pack of gum by 68 cents or for 68 cents. And that would maximize our profit. I just said that we need to increase the price by 23 cents. That's the same thing, because we'd have to add that to the 0.45. So you even went a step farther. That's great. Good job.
Thank you.
Yeah, good questions. All right. So now we are going to go into our note packets. We're going to look at section 410. It's on page 37. Make sure if you did not submit that review, you submit it. We're going to start in section 410, page 37. So here, instead of being given the quadratic function and having to graph, now we're going to be given the graph and make the function. So we're kind of doing the opposite. So here they're saying, write a quadratic equation for the parabola shown. And they tell us 2 points. Is there something special about either of those points? What is special about them? Malachi.
One is the vertex.
Yeah. This bottom one is the vertex. And what about the other point?
The y-intercept. Right.
Yeah. So they're asking us to write the quadratic function in vertex form here. What is vertex form? Who can give me that form? Y equals Lacey, could you give me
Is it
vertex?
like-
Lacey, oh, go ahead. Go ahead, Faith.
Oh, okay.
Go
Is
ahead,
it
Faith.
like x minus k and then mine or plus k?
Yeah,
I
plus
forget
K,
the variable.
H. You got it. Good. And this is vertex form. That vertex is HK. So what is something we can put in this function right off the bat? Riley, what could we put in this function right off the bat?
You can plug in the vertex.
Yeah. So we'd have y equaling, we still don't know what a is, x is part of the function, and we have minus h. So what should we put after this x, Riley?
+2.
Yeah, because it's minus, and that h is -2. So it will be +2. And that k is -3, -3. So yeah, we have a +2 in there. Now, we are going to use that other point. We know that this point, ordered pairs are represented by x, y. So we're going to take that point and plug it in for x and y here to figure out what that a value is, because we still have to figure out what a is. So we'll take that point, put in 5 for y. We still don't know what a is, and x is 0, and everything stays the same. So go ahead and solve for a. Valeria, what should we do here first to solve for a?
Add -3 to both sides.
Awesome. Valeria, what is 2 squared?
Four.
And then we'll divide by 4 on both sides and get a is equal to 2. So we're just going to plug that a equals 2 back into our function. So we get a final equation of y equaling 2. Instead of writing a, we know it's 2. X plus 2 squared minus 3. And that is our equation. So we started with the graph, and now we're making that equation from the graph. Questions? Okay, now let's look at the next one. Example 2 is saying to write a function in intercept form. Who can tell me what intercept form is? It's that y equals Lacey, can you tell me what intercept form is? With the variables.
A x minus p, x minus q.
Awesome. Good. So we have this graph. What can we identify from this graph by what is given? What do we know from this graph? Leah, what can we tell from this graph? What are these points?
The y-intercepts.
Close.
Oh, wait, no, the x.
Yeah, x-intercept. Good. And this other point, that's just some point that they gave us. That's just a random point on that parabola. But we can automatically go ahead and use those x-intercepts to put some information into our equation. How could we do that? What would that look like? Annabelle, what would that look like when we use these x-intercepts?
You could plug them in for P and Q.
Yeah, so what would that look like? We'd have y equals a times
X plus 3 and X minus 2.
Yeah, good. We know that it's +3 because the formula is already negative and it's a -3, so that turns to +3. Then we just plug the 2 in for the second intercept. So now's where that other point comes in handy. Brooke, what can we do now with that other point? We still need to find A. What should we do next?
I was thinking maybe you could plug in that point,
Yeah,
like -4 for y, and then I don't know if you would like pick an x to put the -2, or you would just put it in both of them.
-2 can go in both. They're both x, and they're saying x is -2. Good. Which leaves us left with A, so we can solve for A here. Go ahead and solve. Brooke, tell me what you get for your A.
1.
Yeah, good. So our final equation is y equals 1 times x plus 3 times x minus 2. And we don't really need to write that 1 there. And that's our equation. Questions here? So again, look at what form they're asking you to write the equation in. Identify what is given and what you can already plug into your equation, and then use what's left. All right. Now let's look at example 3. So example 3 says, write a quadratic function in standard form. So this is that last form that we've been talking about, that y equals ax squared plus bx plus c. So they want us to write a quadratic function in this form for the parabola that passes through the points -2, 6, 0, 6, and 2, 2. So here they're just giving us 3 points. When they do that, we are going to use all 3 of those points and make 3 different equations with those points plugged in. So first they give us -2, -6. We are going to plug that point of -2, 6 into our standard form equation. So we have y, which they gave us to be -6, equaling a times x squared, which is -2, plus b times another x, -2, plus c. We don't know what a, b, and c are. That's what we want to find. So we're going to use those points to help us find a, b, and c. So here you can simplify a bit. -6 equals 4a minus 2b plus c. And that's as far as we can go with that one. Let's use the next point. We have 0, 6. 6 is our y, equaling a, x squared, so we have 0 squared, plus b times 0, just plugging in 0 for those x's, plus c. What are we left with here? Gabby Snyder, what are we left with here?
X equaling c.
Yeah. We have c equaling 6. That goes to 0. Anything times 0, 0. This goes to 0, which just leaves 6. Or just leaves c equaling 6. Now, of course, we have to do it for the last one as well. We have 2, 2, that third point. So go ahead and plug it in. So we are going to use the c equaling 6 and plug it into our other equations that we made. So our new equation for the first one be -6 equals 4a minus 2b plus 6. We know c is equal 6. And we can simplify. We'll subtract 6 to both sides, bring those constants together. So that's -12 equals 4a minus 2b. And let's do the same thing for this equation down here as well. We know c is 6. So 2 equals 4a plus 2b plus 6. And combine those constants. So -4 equals 4a plus 2b. Now we are left with two equations still. We still need to find what a and b are. Questions on how we got those equations first. Okay, so now I'm going to rewrite these equations next to one another. -12 equals 4a minus 2b, -4 equals 4a plus 2b. Who remembers thinking back a few chapters how we could solve for a and b? We have these two equations, we have this system. What could we do to get a and b here?
Solve a system of equations.
Yeah. What do we notice we have here? How could we do that? Valerio, how could we do that?
You could use elimination.
Yeah, elimination. When we do that, we see this -2b plus 4b would add to 0. That would cancel. So here we're left with -16 equaling 8a. So we're going to take those two remaining equations and solve using elimination. So then we would divide by 8 on both sides, and a would be -2. Questions how we got there? Okay, so now we could take this a of -2 and plug it into one of these equations we used. Doesn't matter which one. I'll just choose the second one. So we have -4 equaling 4a plus 2b, and we just found out that a is -2. And we can simplify. Questions on how we got there? That last part there. So we're going to take those 3 points that they give us, plug them into standard form. We can see that one of them is solved. Plug that point that is known into the other two and then use elimination to get the final two. So we needed to find what a, b, and c are right up there. So we are just going to plug our information in. We said a is -2, b is 2, and c is 6. So I'm just going to write them in our standard form equation. We needed to find what that a, b, and c are. Questions on how we did that?
How do you think you could use your calculator to check your work?
Can you plug it into the tables?
Yeah, so go to y equals, plug that equation in, and then check the table. That table should have the 3 original points that you were given. If it doesn't, then you did something algebraically incorrect or maybe made a small math error. But that'll work for the other 2 problems as well. So you have a tool to help you check your work.
I have a question about that graph on the calculator. When I press graph on my calculator after putting the y equals in, it says error invalid dimensions.
If you hit second y equals, I believe your stat plot still might be on. And make sure the off
Thank you.
is highlighted. Yeah, it should work now.
Okay, thank you.
Yeah, no problem.
So I have that graph for the last problem up here, and I have pulled the table up. We can see that 0.06, -2.6, and 2.2 right there on the table. So that's a way to check. And you could do that for other functions like Mrs. Kane said too. Plug that function into your calculator and see if those points are in that table. Ella, go ahead.
The same thing's happening to me that happened to Valeria, where it says error, but I checked the table and it says that the stat plot's off. So I'm not sure if I'm just doing it wrong.
Can you hit zoom 6? Did that help?
Something just happened.
A good happen or a bad happen?
Calculator restart because everything's gone now.
Okay. If you want to stay on after class, I can look at your calculator through the camera and I can try and help.
Julia, go ahead.
How do you get the table on the calculator?
You hit second graph. See that little table function above graph? So hit second graph.
Okay, I was just confused where you got it.
Yeah. All right. So it's a great way to check your work, plugging that back into your calculator. So one last thing I wanted to go over. For the next page, they're saying write a quadratic function whose graph has the given characteristics. So here, the first one, they're giving us the x-intercepts and a point on the graph. So instead of actually giving you the graph, they're just stating x-intercepts and point on the graph. And then the second one, they're giving vertex and point on the graph. What function or what form do you think we could use easily for number 1 to plug this information in?
Intercept form?
Yeah, intercept. So we have y equaling x minus p and x minus q. We can see our x-intercepts there. Our x, we would have a +2, and x minus 1. And to find that a value, you would then use this point. And you'll end up getting 2. Eva R., what form do you think would be good to use for the second one if we're given the vertex and point on graph?
I forget what it's called, but the one where it's y equals a and then x minus h squared plus k.
Yeah, it's called vertex form. Awesome. We could plug that vertex in. And then they're also giving you that other point on the graph, and that's how we'll use to find our A. You'll end up getting A as 3/4. Questions here. So instead of giving you the graph, they're just stating characteristics about the graph. And this is what you'll be doing on your homework tonight. Again, it's that practice worksheet. It's on Google Classroom, the outline for you, and you're just writing functions. That is all the time we have for today. Have a great day. Put questions on the form if you have any.
Have a nice day.
Have a
See
great
ya.
day.
Thanks, you too.
Miss Kane, I got the graphing to work.
Oh, good. Good. I'm glad.
Yeah.
Have a good one.
Have a good day.
Cody, do you have a question?